Okay, so I will be talking about what exactly is data augmentation. Yes, my topic is GANs for data augmentation and privacy, but I assume that there are some beginners who are watching this. So I would kind of like do kind of like an approach of an educator where I would be talking about all the big terms that people don't know. So, and then going into what GANs are and how they are being used in these particular texts. So, starting with why do we need data augmentation, or what exactly is data augmentation? So for that, I created this meme some time ago, and it kind of like went viral, at least for me. So this image basically I used. It is not a real exactly what happens in the background, but I over exaggerated these numbers. You can see that what I did is I compared my face with potatoes. So, which means I'm doing image classification, and I'm trying to see whether my convolutional neural networks can identify my face from potato, and if I move images around and things like that. So when I was doing that, I saw that if I rotate my images and then throw it in my model, they were giving me less accuracy. Yes, they were not giving me 0% accuracy. They were giving me less accuracy. I thought, let's make it and let's kind of like make something out of it that everybody can learn from, or things like that. So because I'm a visual learner, and I usually learn things well if I can connect them to a certain picture in my head. So this picture kind of like for me is a very good way to represent or understand what data augmentation is. So what happens in machine learning models is basically, for example, getting my images is, yes, I have been getting my images or taking my pictures since I was a baby, and I have a lot of pictures, but I don't want to throw in all those pictures. So what I did is I just took 100 pictures, and from those 100 pictures, I wanted to train a very good image classifier. So my means so face classification. So what I did is basically, since 100 images are not enough, deep learning models need more data. So 100 images are not enough. So I used transfer learning, different Inception or VGG or several different models, and I compared them. That is a different thing. But what I did is basically using that, you can improve your model. But doing augmentation, you can improve your data set. And even without transfer learning, you are able to improve your accuracy. And this is what I experienced. And this is what I have been seen in different research, and I would be sharing it later. So what I did is basically, without using any transfer learning, I just applied different augmentation techniques. So what is augmentation? Simple. There are two different branches, you can say. One is classical, which is pretty much what happens is you can do a vertical or horizontal flip. You can just do a horizontal or vertical translation, like move the image from the center to left or right, up or down. And you can do rotation in any direction, clockwise, anti-clockwise, like the image that you see over here. I flipped it kind of like vertically, and that is one of it. So this image is being shown here, showing different sort of. So you can see over here, rotation is happening. Over here, rotation is also happening. Over here, a blur is happening. So all those different modifications in the image create a new image for the machine to learn. Because machines only learn numbers, and it does not care about what a picture looks like. It cares about what numbers are in a particular matrix, which is being sent into the model. That means if I change or apply these transformations, my image will have different numbers, which means model is going to perceive them to be different images. And then this way I can generalize my model really well. So that is one way to do it. We call it classical data augmentation. But it has some limitation. For example, like I can just introduce my face. What if I want my face detection model to detect any face? That's where I need more data. I need to gather pictures of other people as well. So if I cannot capture, or if I do not get the consent of sort of different people, I cannot use their images, which means can I use some generative artificial people? That is where GANs come into play. So these are the images that you see on the left side. they are being generated by GANs, and this is one of the paper. So what I'm doing is basically I'm giving links to every image or every research paper that I'm discussing, so you can find those images and feel free to check them out, read them in detail, and that would give you a bit more elaboration of what I'm trying to talk about. So so over here, these are generated, which means, let's say I have a dog, and I have just one dog. Just like I took 100 pictures of me, I took 100 pictures of my dog. And now if I want to train it and I want to make it more generalized, one dog picture is not enough, or one breed of dog is not enough. I should be able to get more breeds. Then I would be able to generalize the model well. And any image I'm going to show it to for a dog, it's going to identify that it is a dog. So it's not just identifying my dog only. It should be able to identify any dog. So these images are generated, which means I don't need my dog only. I can get images from different generative models, and I can use them as my data, and I can train my model on that. So data augmentation using GAN. So why exactly we need it? There are a lot of fields in which we don't have access to a lot of data. One example is pretty straightforward, which is like medical field. And there are several diseases which are very, very rare. Some doctors just get a chance to maybe in their lifetime get to meet one patient of that particular disease. So which means there are some rare disease and we need to find cures. And if we have some data for those particular patients for that particular disease, that means we don't have enough data to train our deep learning models, and we cannot apply deep learning over there. But GANs can come into play in that particular scenario, and we can create some synthetic data using GANs, and which I will be showing you. There are several people who have already done that, so I will be sharing their research and what exactly they have done and things like that. Data is also, some cases, it is very expensive. And in some cases, if you have imbalanced distribution of the data, then you can use GANs. Yes, there are several other, it's just like a smart technique. It is also, there are some papers where they have compared smart techniques and GAN techniques to handle imbalanced data, or kind of like fix imbalanced data, or get or create synthetic data, so that they can compare who is performing better. And GANs have done a really amazing job in that particular category. So, which means these are a few cases. And then there are some cases where, for example, like there are some radiation techniques which you cannot, so like PET scan, you cannot do it on pregnant women. You cannot do it on some different people of some different category who are kind of like, it is not feasible for them. It is harmful for them. In that particular scenario, we have seen several different scenarios where from my face, I can create or I can do image translation from my face to Albert Einstein's face, and whatever I'm talking, Albert Einstein is talking. Technically, so it copies my image and it translates onto Albert Einstein's image, and then you will see Albert Einstein's face moving around, talking just like me. So that same technique have been applied in research where people have created PET scan images from CT scan images of certain patients who are, it is not recommended for them to get PET scan. So now, before I get to that, let's quickly talk about, for any beginners who are out there who don't know what GANs are, how they work, the simple basic mechanism is, there have been a lot of different examples. Yes, we talk about that generative adversarial networks. That means two networks are fighting with each other. But I don't interpret it that way. I interpret it in a bit more positive way. I'm not inclined towards fighting. I'm more kind of like, I love educators and education. So I will give an example of that scenario. So you can assume that you are a student and I am a teacher, and you want to learn how to sketch a particular face, or let's say your face. So which means now you and me are kind of like in a room. What you are doing is you will draw a sketch and give it to me. And then since I have already learned what is a real sketch, what is a fake sketch, so what I'm going to do is I'm going to give you feedback that your sketch is far away from the real. So you need to do this or that. I will give you feedback and you will use my feedback and then come up with another sketch, and you will submit another sketch and I will give you feedback on that one. And I will keep on doing that. On this particular image, what is happening over here, you can see this real world images. So these are for my experience since I'm the teacher, and I'm getting some samples. So what this generator is doing right now, generator is simply, if you have ever made an image classification model or convolutional neural networks. So what happens in convolutional neural networks, you give a matrix as an input and get a column vector as an output. Here, the opposite happens for generator. You start with a column vector and you end up with a matrix. And if you put some numbers in the matrix, machine will interpret it as an image. So technically, image generation is only, it only means getting a column matrix converted into kind of like some 65 by 65 or 128 by 128 by matrix. So, and that is what I'm calling a sample image. So I created some sample image, I have few real image, and then I'm going to compare sample with the real, and then I will say it is real or fake. So here, my role is discriminator's role. So I would call it discriminator in scientific terms. So that is what everybody does. And I would call you as a generator because you are generating the sketch. So what happens in the first case? I'm not updating my model. So I'm also updating my weights as well. And I'm getting better at identifying fake versus real as well, as you are getting better at sketching the image. So which means two networks are being trained together. So it happens in two steps. First steps, discriminator gets updated. Then the second step, when I give the feedback, the generator gets updated. So, excuse me. So there are two backpropagation steps. One updates discriminator and makes it a better discriminator, and one updates generator makes it a better generator. So this keeps on happening until you start producing real sketches, and then I'm not able to identify between whether it's real or fake, and then kind of like you are perfect sketch arts. That is how the working happens for GANs. If you get it, that's amazing. But at the end, you can ask me questions about it or whatever I'm talking about it. Please feel free to ask questions at the end. Let's move on. Now we have a good understanding of what GANs or how GANs work. Now there are thousands of different flavors of GANs. People have kind of like created several different GANs. You can create 3D images from 2D images. You can create realistic images from sketches only. Like some people have kind of like created data set where they have sketches of handbags, and you can create realistic handbags. So there are endless possibilities out there. Whatever you can think of, you can do with them. So what are GANs capable of? Let me give you some examples. This is what I was talking about, the Einstein image. You can see this is a Mona Lisa. It's kind of like most probably Harry Potter created those moving pictures in Harry Potter, most probably maybe using GAN. I don't know, because at that time GAN was kind of like first published in 2014. But I don't know how they did it. Yes, they must have spent a lot of time. But if they had GAN at that time, they would have been doing it pretty fast. So this is one of the examples. And you can check out the complete detailed model over here on this archive website, featured few short adversarial learning of realistic. The other examples is basically you can see you can create some labels and it can convert into a street scene, which means you can just draw some cars or things like that, and it's going to convert a realistic scenario. You can kind of like go from aerial image to a map orientation, labels to facade, and then day to night. And this is the example I was talking about. I have tried implementing it. Yes, because of the limited GPU power I had, I was not getting good results as this paper, but I have implemented it. So black and white to color, these are all possible things. Yes, there are several others. These are just few. And I got these all from this image to image translation with conditional adversarial networks paper on our archive. You can check it out. So, and they provide the data set for this one, because I have tried this one for sure, this handbag one. So I would recommend anybody who wants to get some hands-on practice on it, get the data. It is freely available and you can work on it for educational purposes. So now let's talk about use cases of GANs for data augmentation. First one, gaze detection. This is one of the common, means any gamers out there can relate to this. Not just gamers, even if there are some people who are disabled, for example, like just using gaze, they can select different features. For example, like people who are on not, means who are paralyzed, but they can move their eyes. They can control different functions, means if they want to sit, if they want to move around or something like that. So they can do some motor wheelchairs or something, and they can control those things. So a human computer interface anywhere, this gaze detection is one of the application. Behavior monitoring, for example, like you are looking at screens all day long, which parts you are looking at for how long, that is where GANs comes into play. So and the collecting data for that kind of a thing is very difficult. That is why generated data using GANs would be a good deal. So gaze detection is one field where you can apply these GANs and create some data, and you can create extra data, because gathering data in those particular fields is difficult. Like medical diagnosis. So these are a few use cases you can see. Hands-free gaze as input for patients with motor disorders. Wheelchair motion control using gaze direction, and gaming using gaze direction, means artificial reality and VR, AR, they are getting kind of like very advanced. And we can apply this because we don't have enough data in that particular field, and we can generate data using GANs for those particular kind of like applications. And you can check out this whole paper. This paper was amazing. Means we were giving sketches, means in not we, I did not do it. So scientists were, our researchers were giving sketches drawn by hand, and it was creating realistic patterns, which means it is not, it's kind of like also used for creating realistic images as well. That is a separate use case, but that is one thing it can do. Now, this is the example I was giving, pet images from CT data. So some scientists have done that. This paper used a data set including just 25 pairs of PET and CT scans. And using that, they got an accuracy, means true positive rate of 92.3% and false positive rate of 0.25%. And that is amazing. So for some patients who cannot go through PET scan and they only have done their CT scans, I can create 92.3% true positive case PET scan image for them. And that is amazing, because it is not just always about whether a person can do that or not, because there are some facilities who does not offer PET scans, which means there are some countries where it's very hard to find PET scan. In those particular countries, this scan can help us in great detail. And you can see they are getting this high result using just 25 pairs of PET and CT scan images. So that is pretty amazing. Now, speech emotion recognition is another one. So this is the real speech recognition. These are spectrograms, colored coding of how the variations in the sound is happening as person is speaking, if he's angry, if he's sad, if he's happy, or if he's neutral. And collecting that data is very difficult, because you can include a lot of bias if you collect it. Like, for example, if I'm angry when I'm acting, my sound would sound different, and when I'm really angry, that would be different. And you need to make me really angry in order to record that kind of instance. So otherwise there will be some bias. I mean, my whatever data I'm collecting is not realistic. So which means collecting, even if you can get some people to give you that kind of a data, then you can use GANs to create more instances, and then you can get more accuracy using this. And Alexa and all those platforms, they are using that. So they are kind of like working towards identifying speech recognition and emotions in the speech recognition. So now, some pros and cons of data augmentation. First one, simple, more realistic images. This is the first example that I gave you. This is one of the image from it. So synthetic is the hand drawn, and you are getting a realistic version of it. So that is something good. Generate more labeled examples. That is pretty straightforward. And then you can improve model generalization downstream. So that is our end goal technically, because we want to get a very accurate model, but in order to get it, you need more data. But if you don't have data, then you have some limitations, and GAN can help you with that. Now, some cons. Definitely, there are some cons. There are some limitations. Diversity is limited to the available data, which means it's gonna be able to. So there are several different things that can go wrong with cons. That is a total different discussion. We can talk about it sometime later, but right now I'm not talking about it. So diversity is limited to the available data. As you can see in this image, training set generated. If you give 8, it's gonna create 8. That means different versions of it. That's it, but not more than that. Overfitting is still an issue. That is always there. Then finally, I will conclude. I think I have taken more time. I will just conclude. So privacy, I will not add much. Simple pros of, so privacy is always the concern, means you don't want companies to get data from your phone every day, right? So you are sending data, and they can access whatever you have on your phone, but you don't want that. So there are several different avenues, which means GANs can be used to kind of like mimic or generate a data similar to your data, which means it's not your data, and they can still gather data, which is a generated version, which is mimicking the probability distribution of your data. So that means this way you can control your privacy. So this is one of the research paper. Where they did is basically they trained data on real data and GAN generated data. You can see the accuracy is getting very closer. So nearest neighbor is getting very closer. Support vector machines are getting very closer. So they're getting very good results. And finally, GAN samples are nearly identical. And obviously privacy, when we talk about it, obviously there are several different avenues we can concern. GAN is one of it, but federated learning is something which has been, people are exploring and doing a lot of stuff. I think I will conclude until this point. Because I know some people are waiting. And yes, thank you everyone. If you have any questions, please feel free to ask. Thank you.